Systems of Nonlinear Equations, Part 2. Solve the system by the addition method. Okay, here I have two equations, and I'm going to use the addition method, so I need to multiply these equations by some variable so that when I add them together, one of the variables disappear. So I'm going to try to eliminate the y squared terms. So if I multiply the first equation by a positive 2 and the second equation by a positive 3, then I'll be able to eliminate the y squared terms. So let's first take the first equation and multiply each term by 2. When we do that, we get a x squared minus 6y squared equals negative 16. Now I'm going to take the second equation and multiply each term by 3. So I get 15x squared plus 6y squared equals 39. Now we can add these two equations together, and when you do that, we get 8x squared plus 15x squared, which is 23x squared. And then the y squared terms disappear, and a negative 16 plus 39 is a positive 23. Now I can solve for x by dividing both sides by 23, and we get x squared equals 1. I'll take the square root of both sides, and when we do that, we get x equals a positive 1 and x equals a negative 1. That's because when we take the square root of a whole number, we have positive and negative solutions. Now I'm going to take the values for x and plug them in to one of the equations and solve for y. For x equals 1, I just plugged in a 1 for x in the first equation, and we have 4 minus 3y squared equals negative 8. We'll subtract 4 on both sides, and we get negative 3y squared equals a negative 12. Then we'll divide both sides by negative 3, and we have y squared equals positive 4. So we'll take the square root of both sides, and we get y equals a positive 2 and y equals a negative 2. So that means that when x equals 1, I have y equals 2, and also when x equals 1, I have y equals negative 2. So these are two solutions. Now I can do the same thing with x equals negative 1. So we just plugged in a negative 1 wherever we saw an x in the first equation and solved for y. And we got y equals 2 and y equals negative 2. So that means when x equals negative 1, I have y equals 2, and again, negative 1 and the negative 2. So altogether, the solution to the entire system consists of these four ordered pairs. Solve the following system by the method of your choice. Here we have two systems of nonlinear equations, and I'm going to solve the system using the addition method. I'm using this method because, as you can see, our equations are already set up so that when I add these together, the y terms will be eliminated. So if I add these two equations together, I get x cubed plus 3x squared. And the y terms disappear or turn to 0, and then this equals 0. Now I can take this equation and solve for x. The first thing we want to do is factor out a common factor. So I have an x cubed and a 3x squared. Both of these terms have an x squared in common. So we'll factor out an x squared, and we're left with x squared times x plus 3 equals 0. Now I can use the principle of zero products and set each factor equal to 0 and solve for x. If I look at x squared equals 0, I can take the square root of both sides, so x equals 0. Next, I'll subtract 3 from both sides, and I get x equals negative 3. So my two solutions for x are x equals 0 and x equals negative 3. Now I'm going to take each of these values for x and plug them into an equation and solve for y. I'll choose the top equation, x cubed plus y equals 0. So I'm going to plug in a 0 for x. I have 0 cubed plus y equals 0. So y equals 0. That means that my ordered pair is 0, 0. This is my first solution. Next, I'll plug in an x equals negative 3, and I'll plug this into my first equation. So I have negative 3 cubed plus y equals 0. Negative 3 cubed is negative 3 times negative 3 times negative 3. That gives me a negative 27. Now I'll add 27 to both sides, and we're left with y equals 27. So my second solution is negative 3, 27. And my solution set is both of these ordered pairs, 0, 0 and negative 3, 27.